So now we're going to be back looking at right triangles, and in particular we're going to be looking at the tangent and cotangent functions and how we can use them in some application problems. So first we're going to review the definitions of the tangent and cotangent functions, both for right triangles and for circles. And then we're going to do an application problem that involves right triangles. So first recall the right triangle definitions of the tangent function. So here's our sort of prototypical right triangle. We have our angle theta, we have our adjacent side, our opposite side, and the hypotenuse. And the tangent and cotangent functions are completely determined by the opposite and adjacent sides. So the tangent is the opposite side divided by the adjacent side, and then the cotangent is going to be the reciprocal of that. That's the adjacent side divided by the opposite side. If we're looking at what this looks like on the circle, here's our angle theta. We make our reference triangle that kind of gives us the connection between the right triangle definition and the circle definition. There's our right triangle, our x-coordinate, which is our horizontal side, our vertical side given by our y-coordinate, and then the radius of the circle is the hypotenuse. Once again, the tangent of theta is the opposite over the adjacent, which is y over x. And the cotangent of theta is just the adjacent over the opposite, that's x over y. Now, if we want to look at this in terms of the unit circle, it gives us another interesting definition. Now, the unit circle has radius 1, and remember the x-coordinate in this case is cosine theta, and the y-coordinate in this case is sine theta. That means our tangent of theta, the opposite over the adjacent, is sine theta over cosine theta, and then the cotangent theta, which is the adjacent over the opposite, is cosine theta over sine theta. And the thing that you should recall is that not just tangent theta and cotangent theta, but all the trigonometric functions can be written in terms of sine theta and cosine theta, as we noted back when we were talking about all 6 of the trigonometric functions. All right, so here's the problem we're going to work on. Suppose you're standing 600 feet away from a building, and the angle of elevation from you, and when I say you, that's from the bottom of your feet to the top of the building, is 21 degrees, and the question is, how tall is the building? Well, here's the picture of you. Well, I hope you look a little bit better than that, but there is you 600 feet away from the building, and there's the angle of elevation from your foot up to the top of the building, and that's 21 degrees. And notice what you're looking for is that height x, and that building and the ground make a right angle with one another because the building is going straight up and down, and that gives us a nice little right triangle there. At least if I could draw that hypotenuse straight, which apparently I was having trouble with that one. But we have a triangle where 600 feet is the adjacent side, x is the opposite side, and then the hypotenuse, we don't have the length of the hypotenuse. But the good news is we know the adjacent side, and we want to know the opposite side. Since the adjacent and opposite are what are involved, the tangent function is perfect. Or actually, it could be the cotangent function. Either one will do. But we're going to use the tangent function. So what does the tangent function say? Well, on the one hand, the tangent of the angle 21 degrees is whatever that number is, but it's also equal to the opposite over adjacent, which is x over 600. So we can actually use this equation to solve for x. If we multiply both sides by 600, we get x equals 600 times tangent of 21 degrees. And tangent of 21 degrees is something that one can compute. We can use a calculator to do it, or there are other possible ways of doing that as well. But in any case, that gives us about 230 feet for the height of the building. All right, so now I think you're ready to work on those activities for the tangent function that's on the PDF file included with this video.